Alright, so in this problem, I have x to the power of x to the power of 3 is equal to 36. So I want to find the value of x here. So for my solution, first start with x to the power of x to the power of 3 is equal to 36. Now, I'm going to take the power of 3 on both sides. So now I have x to the power of x to the power of 3 to the power of 3 is equal to 36 to the power of 3. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. And m and n, these two are interchangeable, meaning I can also write this as a to the power of n times m. And if I can write a to the power of m times n as a to the power of m to the power of n, then this means that I can write a to the power of n times m as a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 3 to the power of 3, and we can think of x to the power of 3 as m and 3 as n. So if I switch these two places, I get x to the power of 3 to the power of x to the power of 3 is equal to 36 to the power of 3. Now 36 I can write as 6 to the power of 2. So now I have x to the power of 3 to the power of x to the power of 3 is equal to 6 to the power of 2 to the power of 3. Now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 6 to the power of 2 to the power of 3, that's going to equal 6 to the power of 2 times 3, which is simply 6 to the power of 6. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 3 is equal to 6. Now, I'm going to take the cube root on both sides. So now I have the cube root of x to the power of 3 is equal to the cube root of 6. Now, the cube root of x to the power of 3 is simply x is equal to the cube root of 6 is the same thing as 6 to the power of 1 over 3. So this is my answer. So now to check, I have x to the power of x to the power of 3 equals 36. We know that x equals 6 to the power of 1/3. So now I have 6 to the power of 1/3 to the power of 6 to the power of 1/3 to the power of 3 is equal to 36. Now 1/3 and 3, these two cancel out. So now I'll be left with 6 to the power of 1/3 to the power of 6 is equal to 36. Now 1/3 times 6 is 2. So now I have 6 to the power of 2 is equal to 36. And 6 to the power of 2 is 36. So if 36 equals 36, and because this is right, my solution is right. Alright, so in this problem, I have x to the power of 4 minus 16 is equal to 0. So to solve this, I'm going to first rewrite x to the power of 4 as x to the power of 2 times 2. So now I have x to the power of 2 times 2 minus 16 is equal to 0. Now 16 I can rewrite as 4 to the power of 2. So now I have x to the power of 2 times 2 minus 4 to the power of 2 is equal to 0. Now if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So in this case, x to the power of 2 times 2 I can rewrite as x to the power of 2 to the power of 2 minus 4 to the power of 2 is equal to 0. Now if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is equal to x to the power of 2 and b is equal to 4. So I have x to the power of 2 plus 4 times x to the power of 2 minus 4. And this is equal to 0. So now x to the power of 2 minus 4, this is actually the same thing as x plus 2 times x minus 2. So now I have x to the power of 2 plus 4 times x plus 2 times x minus 2 is equal to 0. So now this gives me three equations. I have x to the power of 2 plus 4 is equal to 0, x plus 2 is equal to 0, and x minus 2 is equal to 0. So for x minus 2 equals 0, all I have to do is add 2 on both sides. These two cancel out, and I'll be left with x is equal to 2. So this is one solution. For x plus 2 equals 0, I have to subtract 2 on both sides, and I get x is equal to negative 2. So this is my second solution. And finally, for x to the power of 2 plus 4 equals 0, well, I'm going to subtract 4 on both sides. So now I'll have x squared is equal to negative 4. Now, if I take the square root on both sides, I get the square root of x squared is equal to the square root of negative 4. The square root of x squared is x. And the square root of negative 4 I can rewrite as the square root of 4 times the square root of negative 1. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So now if x is equal to, the square root of 4 is equal to positive or negative 2, and the square root of negative 1 is I, so I have x is equal to positive or negative 2i. So my four solutions here are x is equal to positive 2, x is equal to negative 2, x is equal to positive 2i, and finally, x is equal to negative 2i. So these are my four solutions to this problem. Alright, so in this problem, I have 500 to the power of 500 over 250 to the power of 250. So, what I'm first going to do is I'm going to rewrite my exponent 500 here as 250 plus 250. So now I have 500 to the power of 250 plus 250, and now I have this over simply 250 to the power of 250. Now, if I have something in the form a to the power of m plus n, this is simply equal to a to the power of m times a to the power of n. So in this case, 500 to the power of 250 plus 250, and that's equal to 500 to the power of 250 times 500 to the power of 250. And now I have this over 250 to the power of 250. Now, this is the same thing as 500 to the power of 250 times 500 to the power of 250 over 250 to the power of 250. And now if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So in this case, 500 to the power of 250 over 250 to the power of 250, we can rewrite that as 500 over 250 to the power of 250. And 500 over 250, that's simply equal to 2. So I have 500 to the power of 250 times 2 to the power of 250. Now, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 500 to the power of 250 times 2 to the power of 250, if I have something in the form a to the power of m times b to the power of m, this is simply equal to a times b to the power of n. So 500 to the power of 250 times 2 to the power of 250, this is equal to 500 times 2 to the power of 250. And 500 times 2 is 1,000, so I have 1,000 to the power of 250. Now 1,000, this is the same thing as 100 to the power of 3. 10 to the power of 3. So now I have 10 to the power of 3 to the power of 250. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 3 to the power of 250, that's going to equal 10 to the power of 3 times 250, which is simply 10 to the power of 750. So this is my answer. Alright, so in this video, I'm going to solve the equation 3 to the power of x plus 3 to the power of x is equal to 12. So, my only variable in this equation is x, so that's the variable I'm going to be solving for. And now for my solution. So I have 3 to the power of x plus 3 to the power of x is equal to 12. And what I'm first going to do is factor out 3 to the power of x. So I get 3 to the power of x times 1 plus 1 is equal to 12. Now 1 plus 1 is 2, so I get 3 to the power of x times 2 is equal to 12. So from here, we want to isolate x. And to do that, we have to get rid of this times 2 by dividing both sides by 2. So now these two cancel out. And I'm left with 3 to the power of x is equal to 12 divided by 2, which is 6. So now I have basically another equation from this much larger equation. So this is much more simplified. I have 3 to the power of x is equal to 6. So to solve this, well, we know that x is going to be a decimal because 3 to the power of 1 is 3 and 3 to the power of 2 is 9. So x is going to be somewhere in between 1 and 2. So we want to find the exact value of x. So how are we going to do that? Well, I'm going to first start by taking the log on both sides. So I get log 3 to the power of x is equal to log 6. And from here, if I have something in the form log a to the power of b, I can move this exponent b to the front. So this turns into b times log a. So I have log 3 to the power of x, and I can move x to the front. So I get x times log 3 is equal to log 6. Now I'm going to divide both sides by log 3 because, again, we want to isolate x. So by doing this, these two cancel out, and I get x is equal to log 6 over log 3. Now, what I'm going to do is rewrite log 6 as log of 3 times 2. So I have log 3 times 2 over log 3. And if I have something in the form log of a times b, this is equal to log a plus log b. So log of 3 times 2 is equal to log of 3 plus log of 2, and I have this over log of 3. So now this turns into log of 3 over log 3 plus log of 2 over log 3. And now these two cancel out, so I get x is equal to 1 plus log of 2 over log of 3. Now, log of 2 is equal to 0.301, and log of 3 is equal to 0.4771. So I get x is equal to 1 plus 0.301 over 0.4771. And 0.301 over 0.4771 is 0.6309. So I have x is equal to 1 plus 0.6309, which is equal to 1.6309. So this is my solution.